Imagine standing in total darkness. It's minus 30 degrees Celsius. You can't feel your fingers. And then, without warning, the entire sky catches fire. Green, violet, crimson, dancing in silence above your head. No screen can fully capture it. No photograph does it justice. People who see it for the first time often cry. But here's what most people don't know. What you're witnessing isn't just beautiful. It's the visible proof that our planet is under constant bombardment from the sun. And the only thing standing between you and those solar particles is an invisible magnetic shield wrapped around Earth. Today we're going inside one of the most spectacular phenomena in the universe, the Aurora Borealis. Most people think the northern lights are caused by sunlight reflecting off ice. That's a myth. The real cause, charged particles, electrons and protons, blasted out of the sun at over 600 kilometers per second. This stream of particles is called the solar wind, and it never stops. Right now, as you watch this, it's hitting Earth. Every single second. But Earth has a secret weapon, the magnetosphere, a giant magnetic bubble generated by our planet's molten iron core. It deflects most of the solar wind around us, like a rock splitting a river. However, near the poles, the magnetic field lines converge and dip toward Earth. This creates two weak spots, the auroral ovals, where charged particles can funnel down into the atmosphere. When they hit oxygen atoms roughly 100 to 300 kilometers above the ground, those atoms absorb the energy and release it as light. Green from oxygen at lower altitudes, red from oxygen higher up, blue and purple from nitrogen. The aurora isn't fire, it's an atomic fireworks show, triggered 150 million kilometers away on the surface of the sun. Here's where it gets really fascinating. Every color you see in an aurora is a direct message from a specific atom or molecule at a specific altitude. Green, the most common. Oxygen atoms at 100 to 150 kilometers altitude. This is the sweet spot where most particles penetrate. Red are rare and stunning. Oxygen at very high altitudes, 200 to 300 kilometers. These photons take longer to emit and only appear during powerful solar storms. Blue and purple, nitrogen molecules lower in the atmosphere, closer to 80 to 100 kilometers. Pink fringes, a mix of nitrogen and low-altitude oxygen, often seen at the bottom edge of the curtains. So when you look at an aurora, you're essentially reading a chemical map of the atmosphere, painted by the sun. And those shapes, the curtains, the spirals, the rays, those follow the invisible lines of Earth's magnetic field in real time. The aurora literally draws our magnetic field for us in the sky. Not all auroras are equal. The sun goes through an 11-year activity cycle. At solar maximum, which we are approaching right now, sunspot activity surges, and with it, the risk of coronal mass ejections, or CMAs. A CME is essentially the sun sneezing, ejecting billions of tons of magnetized plasma into space at up to 3,000 kilometers per second. When a large CME hits Earth, the results are extraordinary. Auroras can be seen as far south as Rome, Miami, even Mexico City. During the famous Carrington event of 1859, the largest solar storm in recorded history, auroras were reportedly visible in Cuba and Hawaii. Telegraph operators reported receiving electric shocks. Some wires caught fire. If a Carrington-level event hit Earth today, it could knock out power grids across entire continents, disable satellites, and cost the global economy trillions of dollars. The aurora is beautiful, but it's also a reminder that we live inside the atmosphere of an active star. Here's a mind-bending fact. Earth isn't the only place with auroras. Any planet with both a magnetic field and an atmosphere can have them. Jupiter has the largest and most powerful auroras in the solar system, hundreds of times more energetic than Earth's, and they never stop. They're also partially caused by its volcanic moon Io, which shoots sulfur into space constantly. Saturn has auroras too, only visible in ultraviolet light, glowing at the poles like ghostly crowns. Mars, which lost its global magnetic field billions of years ago, still gets localized auroras near patches of magnetized crust, like scattered remnants of an ancient shield. Even exoplanets, worlds orbiting distant stars, likely have auroral displays we may one day detect with powerful enough telescopes. The aurora isn't a quirk of Earth. It's a universal phenomenon wherever stars meet magnetic worlds. So, how do you actually see an aurora? You need three things: darkness, clear skies, and timing. The best locations sit within or near the auroral oval, a ring roughly 10 to 20 degrees from the magnetic poles. This includes northern Norway, Iceland, northern Canada, Alaska, and Siberia. The best time? Around the spring and autumn equinoxes, March and September, when Earth's magnetic field is geometrically aligned to interact more strongly with the solar wind. Midnight is the peak window. One counterintuitive tip: a full moon can actually help. It illuminates the landscape, making for more dramatic photography. But light pollution will kill the experience entirely. The best tool for planning, the KP index, a scale from 0 to 9 measuring global geomagnetic activity. A KP of 5 or above typically means auroras visible at lower latitudes. During extreme storms, KP can hit 9. Apps like Space Weather Live or NASA's Aurora forecast can give you alerts days in advance. Slow aerial shot of aurora dancing over a frozen lake. We live on a tiny rock wrapped in a thin layer of gas, orbiting a violent nuclear furnace 150 million kilometers away. And yet, here we are, protected by an invisible magnetic shield close enough to feel the sun's power, but shielded just enough to survive it. The northern lights are not just beautiful. They're a window into forces most people never think about. Solar physics, atmospheric chemistry, planetary magnetism, all colliding silently above your head on a cold, dark night. The universe is violent and chaotic. But sometimes that chaos is the most stunning thing you've ever seen.